Yes or no? And morning we discuss about the file input stream and file output stream also, right? So uh, we were here. File input stream, I said java.io.input stream is the base class, and from that we have java.io.file input stream. And similar way, we said we have file output stream, right? And we said first two version will allow the overwrite. It will create a new file if file is not existing, and if file is already there, it will delete the current content of the file. Whereas the last two uh, are not going to do so, right? So it will have the facility to append the data, right? So let us see the example. We are talking about file input stream and file output stream example. So this is file input stream example, right? As the name suggests, input stream is to read something. So over here we are going to read the file. Okay, so I have to take java.io.file input stream because the methods related to read from the file using the file input stream, all the methods are there, and that's why we have written import java.io.file input stream. We have taken a class public class input stream example. We have main method, and we are trying to read. What we are trying to read is we are trying to read the test out.txt, which is there in my D drive. Up till now, whatever programs we have seen, we have given something like this. When I'm giving something like this, it means only file name and extension. We are assuming that file is in the current working directory in the same folder where I have saved my file. But when I'm specifying the full path, this is like absolute path. We call full path or absolute path. This is called relative path. Relative means compared to the current directory you are searching the address. So within the same directory, it will try to search first. So now I have taken this. What we have is inside the D drive. You can see my D drive. I have a file testout.txt, and we want to read it. Okay, we want to read it. So what we have done is we have taken a f input stream. We said fn is equal to new file stream. Fn is my object to read the file which is there in the specified location. Path is given in the argument. As it returns an integer value, what we're doing is we have taken integer I and we said fn dot read. It will read the file test.out, and we are trying to print, right? We're trying to print. So if I run this program, which is in my teaching material OOP1 demo programs unit 9, right? This is the path. So I have to run the file input stream. Right? Can you see what it has done? What it has done? It has read a single character. Why? Because we have f in, which is going to read the single character. So I can give this I as in while loop, right? We can take a while loop, okay, and we'll say while I is, you're going to read, fine, and when it is not equal to 0, right, not equal to -1, which is the end of the file, till that time we will read and print, right? So the previous code was reading the single character. If you recall our other examples, which was input stream example, right, we did the same, yes or no? We did the same, right? We have taken this, you see we have while dot read, and here also we have the same thing. We have fn dot read, right? And then we said when read is not equal to 0, we can just print it. Fine, fine, okay. Can you see the outcome? Welcome to MEFGI for Java Learning. So that's the content of my file in the D drive. Test it out. Welcome to MEFGI. But I haven't by mistake printed the E. So that's why it's also not here. But now I updated. I saved. It is printing now. Clear? This is file input stream, right? Regarding file output stream, uh, which is going to write the file. If you want to write inside the file some content, right? At that time, you can use the uh, file output stream. I guess I have not taken that example. Okay, along with that, I want to so this is regarding your file output stream. We can write the data inside your file, right? I had one more example where I was appending the data. Just give me a second. Okay, I guess that was using the random file, so we'll go with that. Okay, so here is one more example about your file input stream and output stream. Uh, Along with that, I have another thing also, which is known as the data object, data IO. If you look at the example, the hierarchy again, uh, we are here. We do have input stream, output stream, file input stream, and we have object IO also. Fine. So when I say we have object IO, uh, we are going to use the entire object IO methods to write something in the file, right? So here is that example. We have object IO. To use the object IO, we need a file input stream, file output stream. We need object input stream and object output stream. Now, suppose I have two data 1, 349, and data 2, which is in string. Data 1 is in integer, data 2 is in string, right? So we have, this is current, no? This two data I want to, two values I want to write in a file. So what we are doing is, we are taking a file, right? We're taking a file, we said file.txt, right? So in case if file is not there, it will create new one. Okay, so let me remove that file. This is file.txt. Let me remove it. Fine. What we are doing is, we are trying to write a file, but this time we will be writing inside a file using object IO. So first I'm creating a file, right? I should have the file .txt, right? And then I'm using the out object, right, which is an object of data output stream, right? Output is the object name. Now I'm using this output object to write in the file.txt. So now my file.txt is treated as an object file. Okay, so with the help of this out, I can write inside it. So writing in a file using object output stream, there are various methods. You can write integer, you can write float, write double, you can write object. We know that string is an wrapper class, right? It's a mutator class, right? So what do we sorry, not mutator, it's like a mutable class. So we are using string object here, and that's why when I'm using the output stream to write, I'll say write object. Whereas data 1349 is an integer value. So I can write inside a file using write.int method. Fine. Now, once the file has been written, now I am opening the file, right? This is like file I open in the write mode. So if file is not there, it will create it. Now, when I want to read from the file, at that time I have to open the file in the input stream mode. So I have to use input stream. Are you getting the situation? To write inside the file, we have to use the write operation. Write operation is possible with the help of output stream. So we use file output stream. We created a file object. Now to write in it, we are writing. We are creating as object dot output stream, right? And we are writing it using the write int and write object. Now to read that file, we have to treat that file as an input stream. So we are using file input stream, right, to have the read operation. We created an object file stream equal to new file input stream. Same file we are opening now in a read mode. And we are creating the input stream object. So we said object input stream, object stream equal to new object input stream, and we are giving the file object. And now using read int and using read object, there are two different methods, right? We are printing the data whatever is there in the file after reading it. So we can read it using the object stream object, uh, object input stream object, which is object stream read int, and object dot stream read object. Fine. Is it clear? Right. So what we did, first we created a file. To write inside the file, we have taken the object output string, we wrote the data, write integer and write object method, right? Again, we open the file in the input stream mode because now we want to read. So if we want to read, we have created an object input stream, right? And with the help of read int and read object, we are reading the content of the file. Is the program clear, everybody? Right? And at last what we are doing is we are closing this stream. Output stream we have closed, the object stream we have closed. As we said, to make the resource free, it is always better to close it. Fine. Is it clear? Is it clear, guys? Any question, any doubt? So I'm compiling and now I'm running. Fine. Is it clear? I deleted the file, but when file is not there, it has created it. And now it has returned the data in it. So you can see here file.txt we deleted, but at 1419, right, that is at 219, it has been created here. And here is the content, right? Though this is some encoded type of characters, but with the help of read, we can read it properly. You can see here. Can you see that? This is integer data. Is it clear? Yes or no? So this is about your object I. Fine, fine. So how we can use the object IO? Object input stream and object output stream are the classes which can be used to read and write serializable object. So we have java.io.input stream. From that we have java.object.input stream, which is having the interface object stream constant and interface uh, java.io.input, which is the child of java.io.data input. Right? This is reading the object and this is for writing the object. So we have object input and object output. This is the entire hierarchy of your Java API to read and write the objects. Is it clear? Any doubt, any question? Should I move forward? Yes or no? Should I move forward? Guys, kindly acknowledge. Should I move forward? Okay. So if we see the hierarchy, the way we have, input and output, we also have for the filter input stream, we have data input stream and buffer input stream, right? So data input stream, buffered input stream, and data output stream and data buffered output stream are the further classes, right? So this is the way your input stream class, data input stream class, and data output stream class are arranged. Basically, your input stream is the root class. From that, we have child class file input stream, and from that, data input stream class has been derived. It also have an interface, which is data java.io.data input, which is containing various read method. For example, read boolean, read byte, read character, read float, read double, read integer, read long, read short, read line, and read UTF. Similar way, we have output stream also, right? Data output stream, and for that also we have various methods such as write boolean, read, write byte, write character, write float, write double, write integer, write long, write short, write line, and write UTF. Uh, we also have the another parallel class to your data input stream. The next one is the buffer input stream. What buffer input stream can do is it is used to reduce the number of read and write operation happening. The reason is when I say buffered input and buffered output stream, we are going to read the entire block. Up till now, you have seen that I shown you that one example where we have just in a single character read and we added the while loop, right? We added the while loop to continuously read the data. So what it is doing is it is reading one character, right? Because our operations is happening in a serialized manner, right? So if you want to go a block of data read, like you want to go for the parallel reading entire block together, you want to read, you can go with the buffered input stream, right? So buffered input stream and buffered output stream can be used to speed up the read and write operation. In short, it is used to have the fast input and output processing, which is reducing the number of disk read and write. So how it happens is we'll have a block of data, we'll use buffered input stream, and that buffer will program will use it for read. Similar way for the write, your program will use buffer and output stream object, right? And with the help of that object, it will just write the entire block of data. Fine. And object IO will discuss. Along with that, we have a serializable interface. The serializable interface is an instance of java.io.serializable interface. So the object which we are using, usually what happens with the read and write operation is one character is being read and write, because all the devices which we are using for read and write are the serial devices. Your hardware can have two type, serial and parallel. If you talk about your ports also, we have serial port and parallel port, if you recall your first year, right? So serializable interface must be implemented whenever you want to go with certain read and write operation of an object, right? So the serialized interface is a marker interface, and it do not have any methods, so you do not need any additional code to be implement in your class that implements the serializable. But whenever we are using the object, the process is being used is marked as serialized object serialization. And because of this, it is automatically allowing your process or allowing your objects to be returned in a serialized manner, right? So we have object serialization, which is implemented using the object output stream class. Fine. Fine. Though it's little confusing, but again, I suggest just keep in mind this block and try to read all the methods and the classes detail regarding this diagram. Okay. Now we are moving to next portion, which is about random access of a file. So as we said, what happens when we are doing the read and write? We are just starting from the first character and we are going till the end, right? And at times we do have the file input stream where we can use the append, and at last we can add the new data. But what if I want to go with the random access of a file? Random access is randomly allowing you to read or write your data, right? So that is a provision in the random access of the file in Java. So Java is having a class which is named as random access file. It is allowing you to read and write operations to be happen from any location in the file, right? Right. So all the streams which we have discussed so far, like data input stream, data output stream, file input stream, file output stream, all those streams are known as the read only or write only stream, right? Because these all are the streams which are sequential. Like in a sequential manner, it works one after another. But when I have random access file class, at that time read and write is happening from the any location of a file, right? So that's why a file which is being opened using the random access file is known as random access class object. It is known as random access file, right? So random access file can implements data input and data output interface. So when we are creating the random access file, we must have to specify the mode. The mode could be either R or it could be RW. When I say R, it means read only. When I say RW, it means that file can be file stream allows both read and write operation over the file. So this is the entire hierarchy. We have data input stream and data output stream interface. Random file access implements these two interfaces. So we can create a random access file by specifying file and the mode, right? You can also specify random access file with the string file name and the mode. The file can be closed. We can get the file pointer, the position where the right now which byte is being returned. Length, which returns the total number of bytes from the file. Read allows us to read the file until it reaches to -1. When there is no data, it will give us -1. We can specify the bytes up till how many bytes of array you want to read. We can have the bytes offset and length. So from in between, if you want to read, you can just specify the start and end. Start, that is the offset, and length, it will allow you to read from that portion. Seek will go to the pointer, will make the pointer to go at a particular location, and from there you can start other operations. We can use the set length. to set a new length of the file being used. We can have skip bytes. Suppose you don't want to process over n number of bytes, you can just specify that n as an argument in the method skip bytes. We have write operation, which is having the two variation. Either you can go with the write or you can go with the write offset and length, and can give a specific number to be returned in the file. Now, what we said is random access allows us to write randomly anywhere in the file, and that's why it is possible that once you have created your file, for example, right now in my example, I'm going to show you my file.txt. So let me show you first my file.txt. You can see what is the content. It says this is my file and I write content here, right? This is the current content of my file. Now what I'm doing is I have closed the file and now I'm in the program. I am going to use the random access file class. So I have to write java.io.randomaccess, java.io.io exception in the case file not found. We have taken a public class random access file example. I give a static path, static final string path, myfile.txt. I have main method, right? Inside main method, we are trying to read from the file, right? So there is new method also available, which is known as read from the file. So what I'm doing is I am reading from the file starting from 0 till 18, right? 0 till 18. So this is path, file path. From that, starting from 0 to 18, I'm reading. Along with that, whatever I have read, I'll print it. And now what I'm doing is I'm using the write to file, right? I'm writing inside the file, and I said file path, and I said start writing. I have to write this. I love teaching and Java is my favorite. I want to add this in my file.txt. If you recall, in my file.txt we have the content like this is my file and I write content here. Now I'm saying that write to file at the 31st byte, 31st character. We know that, right? One character is one byte. That's why we are taking byte array and we are just working like that. So over here we have write to file and read from file, two user defined functions. You see, read from file, we have file path, position and size. What we said is random file access object. We say file dot seek position, file dot seek position. What is the position? While reading, I said the position 0. It means from the starting. From the starting, I started reading. So we said random access is having the method seek. So we said file dot seek position. So position is 0 right now. I'm taking a byte array, bytes, and I said read it. Till what I have to read? Till the third position, size. So 0 till size. Okay, so I'm reading the bytes. How many bytes? We said 18. So first 18 characters from my file will be read. Right? So we say file dot read. Then we are closing it and we are returning the bytes. And that's why it will print here. It will print that string entirely here. Right? That is 0 to 18. Now, once I'm done with the reading, I'm calling a method write to file, and I give 3 arguments. First one, the file path. Second, the string to be added. The string to be added is I love teaching and Java is my favorite, and I give 31. Now, I have a function write to file, right? And I said string path, data and position. Data is I love teaching and Java is my favorite, and position is 31st, right? 31. So what I did is I open a file with the help of path, and as I said, when file is opened, I have to specify the mode. So I'm specifying RW. Can you see with the second argument RW? So it will open the file, right, which is there in path, which is my file.txt, right? Up till now, my file.txt is having the content that is, this is my file and I write content here. But now I'm opening the file. I am taking the pointer, file pointer to the position 31 because that's the third argument. And then I start writing the data. What I'm writing is, I'm writing data dot get bytes. So whatever is the string, what is my string? My string to be returned, the new string is, I love teaching and Java is my favorite. So from 31st, it will start writing, right? So what will happen? What will happen when I'll open the file and I'll read it from 0 to 18, it will read the initial characters. So this is my file and I love the, and I write content here. 0 to 18 will be read first. And as we have returned it inside system.out.println, it will print it, right? It will print it. Now, to write the file, we have called the method, and we are going to write I love teaching to the 31st position, right? So let us run and see what happens. Right, so let me just run. First it will read from 0 to 14. So this is 0 to 18. So this is my file N. Even D it has not read. Are you getting the situation? We are reading from 0th index. So this is T is at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So 0 to 17, total 18. Fine? It has read. And it has return also in the file. So let us see what is file write. We have start writing from 31st position because we have taken file.sic, and that's why it would have gone to there. So can you see this? And I write content. Then onwards it has to start. Instead, it has added the content. Can you see this? I love teaching and Java is my favorite. So rest of the byte, I write the content here. So T and T and here is removed, and instead of that, we do have the new thing added over here. So this is called random access. This is called random access. Is it clear? What is random access? Randomly you can add anywhere. File content was already there, but I started writing it, right? So from the given the position, any in a random way, not only in a sequence we are going. We are going to any position wherever we go, wherever we want with the help of sic method. Is it clear? Is it clear? Any doubt? Any question? Okay, fine. So that is it for the random access. So we did something like this. You see, we had a file pointer, right? And we use a sig, so it has taken us here, and then we started writing it. Fine. So this is how we access the file, random access. Now, the chapter number 9 is basically having three parts. I divided into three parts. The part number 1 was about file read and write, text IO and binary IO and object IO. You can see chapter number 9, right? So we had text IO, binary IO classes, object IO, and random access files. Fine. Now we are moving to the next portion, which is about the recursion. So we have 4 points in the recursion. That is problem solving using recursion, recursion helper method, and tail recursion. So let us discuss that. What is it? So before I begin that discussion, can anyone tell me what do you mean by recursion? What do you mean by recursion? You have used recursion in C language also. Yes or no? So can you tell me what is recursion? What is recursion? Anyone who can answer what is recursion? Function calling itself, right? Repetition. When function calls itself, self-calling methods are known as recursive methods, right? So let us understand how we can, what Java says about that, right? So we are at recursion point of unit number 9. You can refer the book Introduction to Java Programming by Daniel Young, right? So we are going to talk about recursion, problem solving using recursion, recursive helper methods, recursion versus iteration, what is the difference, and tail recursion. So as you all said, recursion is a technique which leads to an elegant solution to the problem that are difficult using the simple loop, right? And in some cases, it allows you to develop a natural and straightforward and a simple solution to the difficult problem, right? So a recursive method is the one which calls itself, and here is a very simple example. Let me show you that example. Factorial program, very simple and very, the basic program for the recursion. What is factorial? What is factorial? If I say I have to find the factorial of a 5. What is it? Factorial of 5. I will find it. We want to find a 5 factorial, right? So yeah, path is saying it is something like 5 into 4 into 3 into 2 into 1, right? So it is like multiplication, as Mahek is saying, it is like repetitive multiplication, right? Every number less than itself, and that we have to repeat until we reach to 1, until the last multiplicand is 1. Up to that time we have to repeat. Now when it is 5, it's okay, but you think about when we have 50, when we have to find the factorial of 50, what we have to do? 50 times, we'll do 50 into 49 into 48 into 47 and blah 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 till 1. Fine. Fine. Ultimately, if you put it in a loop, if you put it in a loop, we are going to take a counter variable number, and we are going to do number minus 1 until we reach to 1, right? So the same problem can be solved using the recursive function. You can see here we have not used the for loop. We have not used the for loop, right? What we did is, so this is called recursive method. If you are using the for loop, if you are using the for loop, then what you will do is, you'll take a for loop, right? You say I equal to number, the one for which you are finding the recursive, the factorial. You say I greater than 0, or you can say I greater than or equal to 1. Till that time you are doing I minus minus, and you have taken a variable which is of integer fact. Initially you took fact is equal to 1, and you are doing fact equal to fact into I, right? This is the solution using the recursive. Any programming method which is having the same steps to be repeated can be solved with the two method. Method number one, iterative method. Iterative method. So iterative means iteration, it means for loop. So this is iterative method. Or you can go with the method number 2, which is called recursive method. So in recursive method, usually we are applying a recursion in the terms of designing the recursive method where method calls itself. right? So if we would have gone with the iterative method, this would have been the solution. But as we are talking about recursion, because recursion enables us to develop a straightforward and a simple solution to some difficult problem, we can go with the recursive problems, right? We can go with the recursive method to apply over here. So here is the examples code you see here. We want to ask user enter a number for which you want to find a recursion. So we have taken a scanner class. We have a class factorial example. We have taken a method factorial, which takes n as an argument. We say if n equal to 0, then return 1. Otherwise, return n into factorial minus 1. You see here, factorial method is calling itself. So over here, factorial is recursive method. It is calling itself. Yes or no? It is calling itself. So factorial over here is the recursive method. Right? Now you see we have main method. We have integer I. Right? I guess we don't require this I. Yeah, we don't need this I. We have fact. We have factorial. We said scanner sc is equal to new scanner system.in. Enter a number, right? That number we have taken inside. That number we have taken inside integer number variable. We said integer number is equal to ac dot next int, right? And this number is the number for which we want to find the factorial. So let us say I enter 5. If I enter 5, obviously our answer will be 120, right? Our answer is 120. Right? So if I am entering 5 over here, it is number 5. Now what I'm doing is I have, okay, I need fact 1. We have a factorial fact, and we call the fact equal to factorial number, right? So this is the method calling. So now what happens? What happens? This method will be called only once in the driver class with the argument 5. When you are calling this, it will go here and it will copy the formal argument into the actual argument. So 5 is being copied into n, right? Now it will check 5 is equal to 0. No, it will go here. And what it will make is it will make 5 into 5 into. Then again, it will go here and it will make 5 minus 1, which is 4. But 4 is again calling the method. So again, it will go here. This is recursive call of the method, right? So it will go here and now 4 is being copied here. It will check 4 is equal to 0. No, it will go to the else part. Now we already had the 5 into, now it is adding 4 also. So it will become 5 into 4 and then it will make 4 minus 1, which is 3. Again, we are calling the factorial method. It will go here. It will copy the 3 into n and it will check 3 equal to 0. No, it will go here and it will make 5 into 4 into 3 and it will make 3 minus 1, which is 2. So fact is now having the argument 2. It will call again. It will check 2 is equal to 0. No, again it will call here, go here and it will make 5 into 4 into 3 into 2. Again minus 1, so it is 1. It will come here and check 1 is equal to 0. No, it will make 5 into 4 into 3 into 2 into 1. And it will go here by taking 1, right? And when it comes here, when n equal to 1, it will make 1 minus 1, which is 0. Which is 0, right? And when it is 0, it will go here and it will check. What it will check? It will check that n, which is 0. 0 is equal to 0. It says yes. And when it is yes, it is calling or it is going to the calling method. It means it will go back here. And at that time, we'll have the answer 5 into 4 into 3 into 2 into 1 inside a fact, which will give us 120. So this is called recursive method. This is called recursive method. So if I run Java factorial example, it's asking me to enter a number. If I enter 5, it will give me the answer of factorial, which is 120. Is it clear? Is it clear? Any question, any doubt up till now? Anyone? Guys, kindly acknowledge, say yes or no. Right? So this is called recursive method. Fine. Is it clear? Any doubt or any question? Fine. So this is factorial program. So this is how it works, right? We'll have step 0, factorial 1, and then 3, and then 2. Again and again it is calling itself. And we'll have something like this. This is the record when n, initially we have enter n equal to 4, right? So 4, then 5, and it is keep on calling itself, right? Right. Next time we'll see one more example about Fibonacci series, and then we'll discuss further about problem solving using recursion. Okay. So today we are keeping up with this. This is the entire tracing, what we did about the method call. Here we have taken n equal to 5. In our example, we took n is equal to 5. So we had one more step about this. Fine. Is there any question, any doubt? Say yes or no in the chat box. Okay then. Okay. So that's it from my end today. We'll stop here. Further we'll discuss in the next session.